Thank you very much, Patrick. Ladies and gentlemen, good afternoon. First of all, I would like to thank EMAK for providing IIP this platform to present some of our work here. It is a pleasure to be here. My topic, I'll be presenting how to calculate energy efficiency potential and other benefits in SMEs, taking examples from some of the work IIP has conducted in two of the very energy-intensive sectors from the SME. One is steel rolling and the other one is foundry. Though the last speaker hasn't left much to talk about in regard of SMEs because their contribution to the economy, their share to the export, and the manufacturing output has all been discussed. Talking in context to the energy efficiency, as we all are aware that a cluster-based approach is what is popular in India and, when we talk about SMEs. And in cluster-based approach, the energy efficiency intervention, the technologies. Let me give you some background before I start away directly with the presentation. So in the cluster-based approach, where the energy efficiency interventions and technology, they find a good replication potential, because in clusters, the capacity of unit changes, the process more or less remains the same. So there is a great potential of replication and upscaling the technologies. On the other side, if I talk about at the receiving end, the entrepreneur's end, there is no match as compared to the replicability of the technologies and the approach and methodology which is being followed by the entrepreneurs. Because you can sense out the SME group it comprises a big group of people. Some of them are very literate, some are not so, some are from a technical background, and some are carrying out their business as a heritage, which came along in the family. So it becomes really difficult for a energy efficiency professional or a consultant to penetrate into the mind of that entrepreneur and convince him that these are the energy efficient interventions which are possible in your unit, and these can accrue you this much benefit. So when a consultant approaches energy efficiency SME for energy efficiency interventions, it really becomes a little difficult for him to actually take that discussion to the implementation stage and then start working on the benefit side. So I think that was sufficient for the sake of background. And let me tell you that in my present organization, I came across a phrase called death by PowerPoint. So I'll take care that I do not inflict a major damage to the audience. So there are just 4 to 5 slides in my presentation. So going along with the presentation, this is how I have structured my presentation just to put things into perspective. I'll start with the barriers and motivating forces as they apply to the SME sector when it comes to implement the energy efficiency projects. Something which is very important to take care when we structure our intervention in energy efficiency. Then I'll move on to the subject of direct and co-benefits of energy efficiency projects, a subject which is being increasingly discussed now, and something that the energy engineers and consultants we have ignored for a long time. Because energy efficiency brings along the global benefit, carbon benefits with it, but there are other benefits as well we'll be discussing ahead in the presentation. Then I'll move to the core of my presentation, firstly with a sketch of 2 sectors that I'm going to cover today, and then as to how we see the benefits, streams linked to energy efficiency, which ties in very well with the earlier slide on this. So Having selected these two sectors, these are one of the most energy-intensive sectors, steel rolling and foundry. These are particularly known as the gold mines for energy efficiency. And for last 10 or 15 years, a lot of work has been done in these sectors. For a lot of donor agencies, the sector was an attractive resort for the this donor agencies to invest in and to carry on the energy efficiency intervention in the sector. So then I'll go to the competition of benefit streams in steel rolling, then to the foundry, and this is how I'll end my presentation. So let's start it. Starting from the barriers and motivation in promoting energy efficiency, the very prevalent factor which as an energy engineer I have faced is the lack of awareness and knowledge. Because like I said, the SME constitute a wide group of people who came from different backgrounds and their different capacity. Some in the SME sector, we may even find the machines or technologies or processes which are as old as some 20, 30, 40 years, and some which are as new as 4 or 5 years or at the global standards. So it becomes really difficult to gauge the entire sector at this very, at one factor of lack of awareness, but it is still prevalent. Coming to the right-hand side of this picture, lowering the operating cost. So energy, when we strategize the energy efficiency intervention in any of the plant, I don't think we should only focus on the energy efficiency part of it, because that is not the only stream which would fetch some cost benefits or cost reduction. There are some other benefits associated to it. For example, in the case of steel re-rolling, if we talk, there is a loss called material loss, which happens due to oxidation. At present, it has become one of the major problems for the industry in steel re-rolling, even greater than the energy consumption, because they know how to control it. But oxidation loss, it is very critical to control it. So there's one more venture to energy efficiency, that we should also focus on an inclusive approach, which focuses on the process also, and the energy efficiency, the use of energy or resource conservation. In SMEs, like if I go to the another barrier, which is conflict of investment priorities, I'll take you through a case which I faced in my career. Though SMEs, we have a single ownership, and it is easy for them as compared to a big organization to take investment decisions. For example, an SME, a year or 2 years back, there was a proposal, there was a project in which an SME came forward. They show their interest, and within a week or 10 days, they finalized an MOU to go ahead in the project. At the same time, we also contacted a cooperative body, a government body, to come forward to the project, and to take that decision. It took around 1.5 months for a very organized cooperative government body to take that decision. So in one way, decision making is easy in SMEs, but the flow, the cash flow, there is a conflict in investment priorities. Because entrepreneurs, they are more concerned about the production first and the consumption of energy first. Because if there is some consumption, then only I can save. If I'm not consuming anything, there's no point of saving it. I've already discussed about the improved product quality and access to better markets. Obviously, if I'm producing a quality product, more market ventures will be available for me. I'll not discuss the entire these factors because there's a limit on time. So let's take one more and then go to the next slide. Weak delivery system, Prasanth sir has also discussed about it, like sometimes the technology provider, the local service providers, they come to the SMEs, uh, they do the energy audits, they give the recommendation, and then they vanish out. This is not the way, I guess, to work with SMEs. Hand-holding is one thing which is of ultimate importance, and it is to the local service providers and the technology providers to take entrepreneurs forward with them and create a motivation drives for the other entrepreneurs as well in the cluster. I've seen in the steel relolling industry, I'm talking about the lack of benchmarking and potential assessment. There are units in India which are consuming, if I consider the calorific value of coal, a constant, say 5,000 kcal per kg. There are units in India which are consuming some 60 kg per ton of re-rolled steel. There are also units in India which are consuming some 90 kg of coal per ton of steel. Despite of having advanced technologies available in India, you will not believe some of our steel re-rolling units are still using furnaces which are operated using lump coal, which is a very crude process. It leads to high energy consumption as well as high material losses. So my point of reflecting these things is just to show that there is a lack of benchmarking and there should be a system in place. Let's come to the conclusion after the end of this presentation, I'm sorry. And then comes the reducing the cost of cleanup. You know, okay, yep. So let's end it here. I guess they're self-explanatory and the barriers and drivers. Moving on to the next slide. So like I said, so most of the times energy consultants and engineers, we have talked about energy savings and material savings. These are the direct benefit. Improved product quality is a direct benefit, workplace environment and better environmental compliance. Then comes the increased productivity, increased profitability and growth, access to better markets, safety in workplace, and sustenance of industry, which at the other level, they lead to welfare of workforce, in help in overcoming the business threats, reduce negative health impacts, and a stable employment to the manpower employed in SMEs. Talking about the steel rolling sector, there are around 2,600 units in India, out of which only around 1,167 are registered. The main fuel used is pulverized coal, and in some cases, natural gas is also used, particularly in geographical location where the piped natural gas is available. One of the major gap which has been faced in this sector is the obsolete and conventional design of the reheating furnace. As we already discussed, our SMEs are mostly located in clusters, and there's a significant scope of energy efficiency improvement. Talking about the foundry sector, there are around 4,500 units. Main fuel of source is coke, located in clusters, and the same problem is also here, that conventional designs and obsolete technologies are still prevalent, and there is a high potential of energy savings and material savings. Environmental compliance is marginal. Now, taking the case study, particularly in a typical steel re-rolling mill. So the capacity of that mill was around 4 tons per day. And capacity of the units were 4 TPD, and average daily production 10 hours basis 40 tons. Specific coal consumption in the old unconventional or obsolete technology which was prevalent in the unit was 110 kg of coal per ton of product. We replaced it with a new energy efficient furnace, and the specific energy consumption we got was 80 kg per ton of product, which means 30 kg of direct reduction of coal per ton of product. product. So if I say the earlier technology was obsolete and conventional, I think it won't be fair enough to describe it in this way. So if I talk about the conventional furnaces in the steel rolling sector, they lack in from the very basic thing that is a covered door at the discharge or the entry feeding side of the furnace, to energy efficient burners, temperature profiling of the furnace, insulation. So when I talk about the conventional design, I incorporate all these things. Like when we designed the new furnace, we took into consideration the air leakages, the insulation part, the temperature of zones. Then we introduced energy efficient burners in the furnaces. So this is how we took a leap forward in bringing this technology, which is energy efficient furnace, to the industry. So when we talk about calculating the energy efficient potential and benefit, this is quite simple. Once we do a baseline, it's very important to establish a baseline before we start working in any of the energy efficiency intervention. So in the baseline, it was 110 kgs, and after the implementation, when a post-implementation survey was conducted, we found it is 80 kgs per ton of product, which means 30 kgs per ton of production. So if we multiply this 30 kg into the entire production of the day, we will come to know that this much coal has been saved in the present day. Then comes the reduction of oxidation losses. So let me tell you briefly what are oxidation losses. When inside the furnace, when the amount of oxygen increases up to a certain level, then as we all know, the oxidation takes place and ferrous oxide, the formation of ferrous oxide takes place, which is nothing but the top surface of your billets, which we charge in the furnace, they got oxidized. And this is particularly a material loss. When it comes out of the furnace, you chip these oxidized part off, and then take the billets or steel to the next step. The improved furnace the new furnace has improved the thermal distribution inside the furnace, which led to 3% reduction in oxidation losses. So my CO2 saving per ton of product on coal saving is 0.060 ton per ton of product, and CO2 saving per ton of product on account of material saving is 0.081 ton. So doing it totalizing it, it comes out to be around 1.141 ton. And taking hold of the past production data, how the industry has performed in terms of its production, and just to present a case, we have made certain assumption to make this easier, that 80% of the rolling mills are small, 2 to 10 pH, and 20% are medium to large. Just to structurize this graph, we have extrapolated it to 2030, just to show that how much CO2 savings can be achieved over this period. So we have taken into account the annual growth rate, the past growth rate in production, to quantify that what could be the CO2 saving by the end of 2030. Moving on to the foundry sector. 30 seconds, okay, thank you. So in the baseline case, there was the specific energy consumption was around 136 kg. With the new divide blast cupola, the specific energy consumption came down to 80 kg per ton, and there was a reduction in melting loss to the tune of 5%, and coal saving per ton was 56 kgs, and CO2 savings on account of coal savings was 0.101 ton, and CO2 savings per ton of product in terms of material saving was 0.135 ton, which led to 0.236 tons per ton of CO2. So in the same fashion, we have extrapolated the savings to 2030 to make it a case. And this is what I was supposed to talk. Thank you very much. Yeah.